Okay, let's do some geometry then using coordinates. It's surprising how much geometry you can do by just having a couple of points to work with. So if we look at the picture over here that I've already drawn, we've got a couple of points, A, and the x coordinate we've called x1, and the y coordinate y1, and point B, which has coordinates x2, y2. This notation is very helpful. It's called suffix notation, and it saves us writing out lots of different letters. I'm sure when you were a bit younger you probably would have written A, B, C, D here. So using these little hang down numbers 1 and 2, it saves us using another letter. So we've got then 2 points and the coordinates. What sort of basic geometry would we like to do? Well, most geometry involves the distance between these 2 points. So how could we get a formula for that distance there? Well, the simplest way would be to complete a right-angled triangle here, and let's label that point C. I can now use Pythagoras theorem in this triangle. So AB squared is equal to BC squared plus AC squared. How am I going to get at these lengths BC? Well, BC is the vertical drop from B down to C. In other words, it's the y coordinate here, subtract the y coordinate at that point C. And of course the y coordinate at C is the same as the y coordinate at A. So BC is y2 minus y1, so I square that. Okay, well AC is of course the horizontal distance, which is going from this value of x as x1 along to this value of x, which is x2. So AC will be x2 minus x1, and we square that. By the way, it doesn't matter if you call the lower ones suffix 2 and the upper ones suffix 1, as long as you don't mix them up, which would be a very silly thing to do and you'd get in a terrible mess. Take the square root, and I've got my first formula. AB is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay, what else might I want to do with these points? Well, I might be interested in the gradient. Now, you should have come across gradient before. The gradient of a line is the vertical distance over the horizontal distance travelled. So if we look at this line here, the vertical distance again is BC, which is y2 minus y1, and the horizontal distance is x2 minus x1. So that would be a formula I could use for gradient. And another formula that I might want to use is I might be interested in the middle of this line here. So where is the middle point? Let's call it M. M for middle seems a pretty reasonable letter to use. It's very simply the average of each point at each end, because if I'm at this point here, then my x coordinate is halfway between this x1 and this x2. In other words, it's its average. So M will be x1 plus x2 over 2, y1 plus y2 over 2. Okay. Now, one other thing I think it's worth looking at this point, let's just have a little reflection on the gradient situation. And we might be interested if our lines were at right angles. So if we have two lines like this at right angles, And if the gradient of one of them is m1 and the gradient of the other one is m2, then there's a connection between them if they are perpendicular. We'll look at a proof of this a bit later on in a further lesson, but at the moment we're going to use the fact, you may have come across it already, that if two lines are at right angles, that m1 times m2 comes to -1. And that is much more important than you might think. So we'll put a little circle around that just to emphasize that this is one that people tend to forget. But you'll find that throughout a lot of your course at A level, AS and A2 level, that this comes up over and over again. Okay, so those are my basic formula. I'm now going to try and do a little problem, hopefully successfully. So here's the problem over this side. I'm going to show that these points here, A, which is 3, 4, B, which is 2, 7, C, which is 8, 9, that they are three corners of a rectangle A, B, C, D. And I'm going to then attempt to find the fourth corner. Might look easy, it's actually quite a sophisticated question. So let's draw ourselves a picture. Remember, in all coordinate geometry, you need a diagram. It's very, very dangerous to do it without. Okay, so let's plot our points. A, 3, 4. B, 2, 7. And C, 8, 9. Somewhere up here. So, I can draw this. Now, if you do it reasonably accurate, you get a feel of what's going on, and you can sort of see here, can't you, that looks like there might be a right angle there. So where is the other corner of the rectangle going to be? It's going to be over here somewhere. Now, a lot of people don't see the quick way of proving that ABCD is a rectangle. And they start working out lengths of sides and looking at whether the length of each opposite side is the same, these sort of thing. But essentially, what I need to prove is that is 90. What's the quickest way of the formula I've got in front of me of proving that is 90? Well, it's this, our friend down here, the m1, m2 equals -1. So, the gradient of BC is equal to 9 take away 7 over 8 take away 2, which is 2 over 6, which is a third. And the gradient of AB, then 7 take away 4 over 2 take away 3 is -3. That's brilliant, isn't it? Because if you look at this straight away, you can see that a third multiplied by -3 is of course -1. So I've proved that ABC is 90 degrees and that this is part of a rectangle. So angle ABC equals 90 degrees. So that's the first part of the question. In an exam question, that would probably be worth 3 marks, something like that. Now, how am I going to find D? Well, you might think, again, that's pretty tricky. And some people start to get into finding equations of lines and parallel lines and where these lines meet to establish where D is. We don't need to do any of that. It's really amazingly simple, because A to D is of course exactly the same as travelling from B to C. And if we remember some of our GCSE vectors, then B to C, let's call it a vector, would of course be along 6, 6 that way, and up 2. So along 6 and up 2. A to D then, let's put a little arrow to show that that's a vector. A to D, again, is exactly the same. So I've got to go along 6 and up 2. Where am I starting? I'm starting at the point 3, 4. So if I look at the x coordinate, so let's try to find D then. So x, I'm starting at 3 and I'm going along 6. I get to 9. The y coordinate, I'm starting at 4, I'm going up 2, takes me to 6. And I've done it. Virtually no work at all, and D is the point 9, 6. Okay, so that's the complete solution to that sort of question.